All right, we'll go ahead and get started. Welcome to our webinar, Building Resilient Applications, Smart Approaches to Chaos Engineering, Observability, and AIOps. We have some great speakers from Steadybit, PagerDuty, and Lumigo today. But before I hand it over to them, I just wanted to go over a couple of quick housekeeping items. All participants will be on mute throughout this presentation. If you do have any questions, please do feel free to submit them in the Q&A, and we'll try to get to as many as we can throughout the presentation, or save a little bit of time at the end for the Q&A. A recording of this webinar will be sent via email to all attendees, and we'll get to, like I said, as many of those questions as we can. If for some reason we run out of time and aren't able to get to all of your questions, we will be happy to follow up via email after the presentation. So with that, I'd like to hand over to our presenters today, Benjamin, Barry, and Justin, to go ahead and introduce themselves.
So, yeah, thanks a lot for having me. Barry, would you like to go first?
Yeah, sure. Hi, I'm Barry Solomon, Solutions Engineer at Lumigo. I will be presenting on observability and troubleshooting.
My name is Benjamin. I'm the co-founder and CEO at Steadybit, and you can call me this paranoid guy. I don't trust the system until I was able to see how it's working under even bad conditions, and that's why I'm doing chaos engineering.
And yeah, thanks for your time today, for everybody who took the time to attend. My name is Justin Roberts. My title is Senior Solutions Consultant over here at PagerDuty, but I actually work within a unit within PagerDuty, or our Automation Center of Excellence. So I tend to work with current customers, future customers, helping them understand a little about what we do and how we do it. So again, any questions, let's get them in the chat, and be more than happy to answer those as we go through. So we should have an interesting set of presentations today. So looking forward to some interaction. Benjamin.
Okay, let me set the scene. Yeah, today's systems, they are quite complex. They are quite dynamic, and we all have to take care about them. We all have to spend a lot of time to maintain those systems, to build those systems, but also to keep them up and running. And to keep them up and running, you need the right tool in place. You need a tool like Lumigo to see what's going on in your system. You need to see how the system is able to handle the traffic. If something goes wrong, you need to be informed. You need to see what's going on. PagerDuty can help you to identify incidents in the system, but also to see how you should react under those conditions, because you can learn something. An incident isn't something bad, so there's a lot of data in. If you have the right tool like PagerDuty, you can see, how can I fix this situation, because someone else was already in the same situation. And yeah, what's the job of Steadybit? With Steadybit, we would like to help you to be more proactive, to use the data by Lumigo and PagerDuty to see and train yourself, train your team, train your technology stack to be more prepared for the bad situations in production and do it in a proactive approach. So, and let's talk about chaos engineering first. So what is chaos engineering? There's a famous quote out there by Russ Miles, and he describes the chaos engineering approach in a way that, chaos engineering is, oh, wait a second. So hopefully you can hear me now. So chaos engineering is a way where you can run experiments in a thoughtful, planned way. And those experiments are able to reveal weakness in your system, in your socio-technical systems, before they appear into production. And there are very important parts in that quote. First of all, thoughtful, planned experiments, but also in the last line, before they appear in production. So you can train yourself, you can train your system, you can train your organization, and with the right tools in place, you are able to learn a lot of it. And now, let's talk about this term, the socio-technical system. What is it? This is a group of people with a strong focus in combination with technology that is needed to provide a service, to provide, let's say, an application. But it's really like the interaction between the people and the technology, because there is one specific focus and what could be a potential result of such a socio-technical system. Let's say it's a simple online shop, really something really simple. And if you take a look at it, it seems quite nice. Some products, you can buy some products, you can get information about the product, but that's just one look at it. There's more behind. Let's go on the technical view. To get this system up and running, we need a lot of components you can see on the right side. So this online shop is running on top of, or is based on Kubernetes. This Kubernetes cluster is managed by a cloud provider. So a lot of components are needed to provide that service. Let's group them in a different way. Let's group the elements more like the deployment, or like their use case. And I just grouped the elements by the deployment name of Kubernetes. And now you can see, okay, it's still a big group. And okay, they are now quite organized, but still, that's not a job for one single person. That's not a job for one single team. So there are more teams involved to provide this simple online shop. And talking about teams, it's not just one team. And inside of a team, there are a lot of team members. And this means there is also a lot of interaction between the people inside of a team, but also interaction between the teams. Why? People would like to learn from each other. They would like to share the experience. They would like to get help from someone else. Maybe he's in the same bad situation, or maybe there is a big challenge how to implement a new feature. So it's a lot of interaction on the technical side, on the left side, and also on the organizational view, or the organizational side. Let me get to the first part on how to build resilient applications. There are three phases or steps you have to do. First step is you need to uncover the risk in your system. So if you are building something new, or you are maintaining an existing system, you need to be aware of the risk in the system. You need to see how big is the list of potential weakness in my system. And that's something a tool like Steadybit can help you to identify in a very proactive way before you go into production with your new feature or a bug fix. The next important step, you need to understand the impact. So why? Because it's under your control, and you are responsible for taking care about the risk and the prioritization of each finding. And to measure them right, you need to understand what is the impact. So you need to have a tool in place that can help you to identify the risk, but also to help you to score them right, to bring them in the right order. And now we can direct jump into the first demo to see how you can do it with Steadybit. So the same picture as in the slide. The system on the right side is not grouped, is not organized. That's the first step I would like to do. So Steadybit was able to discover my system, to see what's going on and how many, we call them targets, are part of your system. Next step, I would like to group them by the Kubernetes deployment to see them more in a structured way. Okay, what's now? Next step, I would like to see a risk just based on the data on the right side. One way to do it is I can use some colors. I can tell Steadybit, okay, I'm running on a cloud environment. Please color all the elements by the zone they are running in. Now I can see there are just two zones. And those two zones are responsible for the whole system. And on the right side with the color concept, you can see that some elements are distributed across two zones. Quite okay. So a low risk, but the hot yield service, some other services like the order service, they are just limited and executed by one single zone, which is already a risk in the system. That's one way to do it with Steadybit, but we would like to enable you to be faster and also to learn a bit more about your system and how you can improve it. There's this feature called advice. And this advice feature you can just enable, and then Steadybit tells you in which area you should set your focus first, because there is a high risk in your system. I can zoom in the fashion bestseller again. Steadybit was able to identify a potential risk on the Kubernetes deployment level. Let me jump in. That's the list of all the checks we have executed, and we are doing it continuously for you to see, let's say after a new feature, a new deployment, something changed in the system, and we are doing this check again and again for you automatically so that you are safe every time and you are getting a list about all the good stuff, which you have done quite okay, like the green ones, but also we are able to help you to identify a new risk in your system, which is like this red one. And the idea behind this advice concept is it's not about just finger pointing. It's really like, okay, that's a finding. We would like to tell you why. And also, what is the story behind? What is the motivation? And how you can fix it. So this snippet here, you can just use to jump into your code to improve your system. And then after the deployment, Steadybit will check this again for you to see if this change is now taking care about the risk. If so, a red one is turning into an orange one, like the CPU consumption or the pod deployment. Let me jump in. Someone improved the system already. So this action, our advice, was implemented. That is a change in the system. What's now missing? You need to validate, verify, or in other words, understand the impact, if it's still an impact for you or not. How to do it? That's where chaos engineering comes in, where we can create an experiment for you automatically based on the data, and you can just jump in to see what is the experiment looking like. And now we are in the designer of Steadybit to run and create an experiment. And it's quite easy to see what's going on. So in the first 20 seconds, Steadybit checks if all the pods are up and running, or in other words, if the system is healthy. After 20 seconds, we will delete a pod to see if after 60 seconds, the pod is getting, or the deployment, the pod is getting back to normal. So that's our expectation. We would like to build a system that is able to handle this outage and is getting back in 60 seconds in the normal state. Also, Steadybit is taking care to check and verify if the pod really was killed. And if you want, you can improve this experiment template. You can use Lumigo again to see about the success rate. Is everything fine, or is there something detected by your monitoring tool? In combination, also, we are able to get some Kubernetes events so that you are getting a nice report out of it. And that's like the next step in the presentation where I recorded a video. Why? Because this experiment is running roughly about 2 minutes. And I want just to use the fast forward function. So single pod was killed, checking if the system is getting back to normal in 60 seconds. Dip, 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 dip. Here we go. Now it's getting green back, which means the pod has recovered. We are getting some events by Kubernetes, and also we are now collecting a little bit more data to see if everything is still okay. So in total, the experiment runs 2 minutes. And this experiment you can run every time. That's something you created now automatically. And this is quite helpful to use this experiment in a kind of regression test. After every new deployment, you can run the same experiment to see if you're still able to survive such a condition. That's it from my side, the first part. And now, welcome to the stage, Barry.
Thank you. Thank you, Benjamin. All right. Let me share my screen. Okay. I have to say, every time I see that, that's just awesome. It's just very cool how that all works together. So, all right. So now, when we have issues, such as when we're running Steadybit, when we ran this earlier yesterday, we generated a lot of traffic. We're going to be looking at in a moment. But the challenge is finding the root cause when issues come up, whether it's pods being killed or due to some exceptions or errors in communication or services, or what have you. How do you find these distributed systems? They're like ridiculously complex. You've got all these different actions and services all running and interacting with each other. When you actually do encounter an error, what is the context? How do we know what data is being passed from one system to another? Oftentimes we'll use logs, but that gets insanely expensive, as sometimes logging is more expensive than hosting of the system itself. As well as if you go to tracing, which Lumigo is known for, but we also do logging now, so we do both. But tracing in general, or historically, has just taken too long to deploy and to add all the hooks and everything that you need to get the tracing. And this is where Lumigo can actually come in and be of service to you. Okay, so an ideal state, so tracing deployment. How quickly can you do it? If you've got your services, your containers, when you create them, if you can add tracing to them automatically to give you this contextualized data as data and systems are interacting with each other, how you have the ability to have full visibility into the system all within a single pane of glass. This would be an ideal state where when I or anyone as a technical person coming in to diagnose and trying to figure out what's going on has all the information in context so that you can visualize and very quickly see what is going on. This is where Lumigo comes in, where we are able to troubleshoot your microservices in context with logs, with all the information that you need to make your mean time to resolve fast. 80% faster, give or take. It really depends on. This is actually not a made up number. We have had many customers tell us that they have been able to resolve issues in minutes versus hours, days versus weeks, years versus epochs. You get the idea. This is what we will help you with. Okay. The easy to install tracing with Kubernetes. We have an operator. Install the operator into a namespace. We will automatically instrument your Node, your Python services, pods. We will instrument those, as well as if you are also using Lambdas, any kind of serverless, we also will automatically add layers and put everything together, SQS, SNS, Kinesis, EKS, ECS, what have you, okay? We will then automatically capture and, more importantly, contextualize all the payloads. So you will actually see the events, the data passing through your system, the responses, environment, etc. And I'll show this in just a moment. Okay. This data will then also be correlated with logging data. So you now don't have to choose between logging and tracing, because sometimes logs do have information. Your logging could be a debug log, a warning, an error, even just info logs. This information, we can search for this. We have a full SQL support for this, that you can find some piece of information, grab that string, pull on it, and literally see the transaction itself, full context, and you can go back and forth. It's really, really sick. Okay, now, this enables us, as I mentioned before, to be able to solve production issues fast with these correlated logs and traces. You know what, let's just go switch over to the demo now. Okay. All righty. Now, so Benjamin had run, like I said, he had run that recording that we ran that last night. During that time period, PagerDuty Lumigo was watching the system, triggered an error when it occurred. And where are we here? It was, here we go. We have a socket timeout. So he was running a very heavy load test. We hit an error of Java socket timeout. And you can see the time frame is a bunch of hours back during that time we were running this. At which point we have an alert. Now, the beauty here is because this information has been passed to PagerDuty, if we have a runbook automation or something that we'll get to in a moment, it potentially could be resolved right through PagerDuty. However, in this case, if we have an issue that we need more information and we want to look at it, we can come into Lumigo and we can view this error. So it's all seamless. Okay, here we see we got our timeout, we have our stack trace, and this is the execution log. So this is the actual invocation itself. Right? We can then say, okay, we made a call here. We have our timeout calling this service. We have, like I had mentioned, we've got our stack trace. We can see environmental data, what's going on. We can see our open telemetry spans as well. This data can be seen contextually. And if we want to see the entire flow, we click on this and we see that this is a much more complex flow where we could literally go in and we can follow the data as it goes through the system so we can see how our system is working contextually. In addition, maybe there are issues where it's a timing issue. Maybe something timed out or something didn't happen, which then had a cascading effect. This is where the timeline view comes in. From here, we can see the time, how, what called what, how these went together. We can see, okay, here we have this entire transaction took a little over 2 seconds, but we can then further see that it was mostly a timeout. And as we go down, we can see how everything goes together. We can also look at logs. We can look at other issues, all sorts of things. So this issues page is a good place also to look around where you can see issues as they come in. These are, maybe we're not alerting on everything, but this again gives us information about the system. We can see, with our pods, we can see what workloads we're running, what events are happening, how often they're being called. If we want to click through to here, we can see the events, how, what's going through the system. We can, look at durations and times, a lot of things here that we just unfortunately don't have time to get into. Okay. Now, from here, if we have an issue, we can open this up in Explore, where this is a really, really great advanced search capability. Let me remove this filter. What we can do is you can see all the different services that are being called, the percentage of all the transactions over this time that were part of this. So again, if we were having anything in SQL, we could go look at our SQL calls or Kubernetes. This includes all sorts of AWS services, the different resources. If there were any issues during this time, here we see that we had a couple of issues. We could look at durations. We could set alerts based on these durations, which would then be sent over to PagerDuty for people to triage and potentially fix and resolve. A lot of things that we can do here. Okay. At this point, and also we could look at logs if we wanted to. So real quick, let's take a look at some logs. Here we see we have some logs coming in. If I wanted to, okay, in this case, this is a log for a Lambda. From here, we could then delve into this, see any kind of details, go back to the full page request, and here you go. All right, so I'd like to hand this off now to Justin to take it from here, where we have alerts going to PagerDuty.
Thank you, Barry. Okay, so I mean, it's really obvious from the first 2 parts of this presentation that there's, a common theme around complexity and context. And I think I will carry on with that theme a little here also. Let me share my screen, and we see where we go from here. Okay, hopefully you can see that. Please shout out. I'm sure John will grab me. Yeah, so for those of you who don't know us, we are PagerDuty. Been around a little while now, probably something in the region of 2 million users of PagerDuty, and around about 20,000 customers. And you know, we are very happy to be presenting here tonight with Lumigo and Steadybit, because it's partners who like this that can help really drive better experiences for DevOps or traditional operations teams who, you know, really want to do the best to get that operational resilience. So I'm actually here to talk a little about our AIOps part of the platform. Most of you will probably, or some of you will know us from around incident response, around getting somebody out of bed, and this is all part of this story. But I specifically I wanted to talk about AIOps because of actually the time that we've got. But there were a couple of things, and one, I really like this quote that appeared around about being a DevOps person, and I think I'm actually going to try and have a little bit of a look at sort of people in this as well. So we must not forget that there are kind of, you know, humans in this loop for technology. And you know, there's this quote about, you know, DevOps being a decathlon, where you've got to be kind of good at all sorts of things. But then I also found another quote that was that was also about DevOps, and I'm guessing it was kind of a little bit tongue in cheek. But the events change every few months, and we hear a lot about the cognitive load that's on DevOps teams. So what I wanted to talk about was kind of what happens post alarm when you get a notification that something's wrong, and potentially some tips that I've seen work with customers, things that are either quick fixes or easy ways to really drive that better experience, and ultimately less downtime, more learning also. And I think you know, Benjamin talked about, you know, an incident not necessarily being a bad thing. It's a learning opportunity each time that we go through this. We also know that this unplanned work also will happen. You know, it's inevitable. So let's not pretend it won't. You know, you can start to mitigate. You know, Steadybit will help you mitigate some of this, but we just have to go with a mindset of, look, we know that incidents are going to happen, but we need to do our best to make sure that they're of least downtime possible. My team have as much information as they possibly have to hand to fix it quickly, rather than, you know, as Barry said, rather than it taking hours to fix. We're looking at minutes. We want to drive that mean time to resolution down. And what do we know? Teams are under pressure. More and more data. You know, everybody. You know, nobody ever comes and says, "I want more data." Everybody says, "I want more information." We know that resolution times can be long in more of a complex scenario. And the third part is a little bit more about automation, really. But we know that organizations say this, that they have to spend a lot of time doing, you know, I guess wasted time, you know, manual tasks, things that are kind of like grind jobs that they have to do from time to time. So AIOps, I believe, is something that can help start to address this. There are always going to be people in the loop. The interesting thing about AIOps is that I think between the analysts, they can't really come up with a solid definition. It's unlike something like which is really well defined. I think if you look at the analysts, you'll see that, you know, Forrester's got a slightly different approach to Gartner, to 451 research, or right the way through. I mean, I quite like the 451, any tool in the monitoring and incident response tool chain that uses machine learning technology. You know, the idea of having, you will never get to that point where you've got this magic black box that's just going to solve problems for you. But you can definitely use things like machine learning to understand, you know, how did something happen last time? Who fixed it? You know, what was that route to fixing it? And this is maybe how you do this again. So I'm going to just talk briefly about our view on this, and really this is the idea of this. Some things that you can possibly consider to just to make life a little easier. So I think before you start to even think about what you do with events, you've got to make sure that signals are solid. You know, if you end up working against noise, this will grind a team to a halt. You know, if you've got duplicates in there, how do they know which ones to deal with? How do they know, you know, is this something that's important or not? And unfortunately, you know, one of the things for us, I think we have over 700 integrations, and I don't think it would be very popular, but I could rank the quality of, you know, some of the signals. Are they noisy or are they not? And, you know, I mean, I looked at the quality of the Lumigo signals, you know, very good. You know, Datadog's pretty good. Prometheus, for example, some of that is dependent on how it's configured, but it can be a pain. It can be noisy. It can be flappy. So the first thing we do before we even think about anything else is get those signals into a state where they are actually actionable. So deduplicate them, suppress the ones that are not important, pause the flappy ones, add new extra data to the signals, because again, you know, you might not be getting data just from one source, and then finally orchestrate them, decide where it's going to go, decide where things are going to actually sit. Back to this context, all three of us have mentioned context. You know, we need more context. Okay, so let's assume that an alarm's happened in Lumigo. I've determined that this has got some impact in my organization. It's 3 a.m. A lot of people mention the 3 a.m. time. I've got a lot of questions when I wake up. You know, my phone's ringing. I've not answered it the first time, so it's gone through like an escalation path or whatever. So then I pick it up and it's like, yeah, what's going off here? I'm already in that state of, you know, sort of anxiety a little bit, really. It's just like, you know, how am I going to fix this? There's a lot of information a lot of questions that I have, you know, what has changed recently? Who's done any pushes really? Has anybody moved any config? What do we know about this kind of problem before? What sort of diagnostics do I need to run? And maybe what caused it at the end? So all of these things, all of this context is something that we can give to a responder to help them just be more prepared, just to be ready to shorten that time down for actual resolution. So first tip, quick win, diagnostics. Now, I know that many of the observability tools give quite a breadth of information. You know, some of them are very deep. Lumigos are, you know, quite deep in what it offers. But quite often, the first thing you would do is a set of your own diagnostics. Let me just go and check that environment. Let me go and have a look if you know, let me have a look if this service is still running. You know, it may be internal, maybe external services. Maybe I'll go and grab some runbooks. Diagnostics is a great way to actually shave 30% off your incident time. So when going back to that point that I made earlier about us having a view of, you know, 20,000 customers, we can actually see what happens in incidents. And we know that 30% can be shaved off simply by hitting diagnostics, adding some diagnostics. Another kind of aspect, something that you might gain value from very quickly, is also to have human-driven runbook automation. Okay, so this is where maybe different members of the team, maybe more skilled members of the team, can pass over key tasks to maybe to responders or first line support, for example. Only things that are, you know, within a boundary of safety. You know, they can only run very specific tasks, but it stops the escalations. It stops you having to pull in many people into the same problem. And then the final part is I guess autonomous. It's everybody's dream where things are just being fixed automatically, and it can be done, right? You know, I'm not saying don't, you know, what I'm actually saying is don't expect it for everything. You need to have solid problem signatures in order to have some sort of autonomous resolution. And quite often it's not really resolution, it's just get it running again. It's restart some pods, it's restart a service, it's maybe, you know, scale up some extra resource or clear temp files down. There's a few things that you can do to actually keep your service running, but it's not really fixing things. It's what it's doing is reducing your downtime. And I quite like this one. A guy called Rod Michael, I think he's from Rockwell Automation, just basically says if you automate a mess, you get an automated mess. And a big thinking about that is, of course, is the idea that you've got to have these solid signals before you even try to do any sort of automation. So for me, at this point, given the time, I'm just going to give you a quick demo. I want to show you a couple of things, if that's okay. So for those of you who've never seen the PagerDuty UI, this is me in my environment, and I can see I've got a service graph of my business and my technical services. So this is a much higher level than, you know, say the deep detailed graphs that you know, that both Benjamin and Barry showed today. But I can see I've got a problem, and that could directly correlate to a status page, internal status page, external status page. And I can also take a look from here from my operations console. So for those of you that know PagerDuty or have worked with us before, we're just about to release this operations console for kind of more of a dashboard overview for you know, for NOC type environments. Anyway, I can see that there's been some events triggered. I'm going to hop into one of these and take a quick look and see what we can see in here. So this is my single pane of glass for my resolution. So, you know, this generated by Lumigo in this case. Let me go for another one up here. Bear with me 1 second. Let me just grab another service here. Excuse me. Okay. We grab that one. So grab my service here. There's a Kubernetes issue that I saw come through from earlier. So I've got all this information now at my hands. Of course, I can drop straight back into the tool I want to use to, you know, to maybe to dig in further. But I also want to provide my responder with a whole lot more information. So if you take a look on the right-hand side, you can actually see. In fact, let's do it from the timeline. You can actually see all of the things that have happened automatically. So, you know, obviously I was notified that there was a problem. But then I've ran some runbooks automatically. I actually tried to start some pods. That failed. So, well, I did the detection. Those pods had actually stopped. I tried to restart them because that's worked for me in the past. And then on the third one, I actually printed out directly the offending lines in the logs also. So again, you could go and look elsewhere for this. I want to try and give my responder as much information in that single pane as possible. And I've got a log of all of those tests that I've been running here, for example. And you can see these. What is quite cool is I've got my steps here, for example. I can actually use Gen AI here to almost to give me an idiot view of what's happened. And, you know, like there's a lot of data, there's a lot of logs. Try and make sense of this for me. And this is also quite useful in our Copilot part of the product where, you know, where you can jump into Slack and say, hey, what's going off? And it'll give me a resumption. You know, I can see here, look, given the persistent exec format error across the pod restart, it's a very advisable to investigate the Docker entry point.sh script. And that is actually the problem. It's my environment. It's a it's a crashing container on here, for example. So, you know, we have that mechanism then now to start to mobilize people, add additional responders, define them as, you know, incident commanders, escalate the data if we need to do that, all from this single UI, but still have the ability to jump back into the individual tools that have gone to make up this incident as a whole. And then, of course, we get to the learning part. If I decide to resolve the issue, and I resolve it here, for example, it asks me, do I want to generate a post-mortem? And a post-mortem is just simply a learning exercise that we all use to, and I'm using Gen AI to actually generate that for me at this point. And that will give me a nicely formatted document to save me time, just to save this load that that individuals get on their that get on them in the night. I want to reduce that that cognitive load actually on the team, not just having to learn, but also that pressure of being on call. So that's that from me. Back to you, Benjamin.
Yeah, thanks a lot. And now I guess the story is getting clearer, that not only technology is needed, but also you need, like Justin told us, the human factor. So people are on call, people are sitting in front of a system, and to be honest, maybe most of the time they are more hunted by their own systems, and we would like to get out of that situation. So we need to improve our system. We need to prepare our system that this can handle specific outages. And that's something, yeah, I would like to demo right now in the next session. Here we go. Screen share again. So welcome to part 2. In the first part, I talked about to uncover the risk and also to understand the impact. But now let's talk about how to strengthen your organization and how to increase the systemic resilience in your organization, in your technology stack. So, as already talked about this in the beginning, it is really like improving not only the technology stack, but also like how the people are interacting, how they can learn from each other, how they can get like data from the postmortem analysis of an old incident with the help of PagerDuty, but also how they can learn with the data from Lumigo, from your monitoring tool, to see, okay, what went wrong, what was the root cause. And it's really like it's both worlds. And on the left side, the technical side, yeah, that's most of the time the area we are working in, but also in between the people. There's a lot of stuff going on, and this is very important. So I would like now to run an experiment. I would like to design a scenario, and I'm starting from a technical point of view. And the scenario is like latency spikes in one backend service called hot deals. But this was not the only issue. This was followed by a total outage of a central gateway component. That's like the scenario from the technical perspective. And one core element in chaos engineering is you need to start with your expectation. You need to describe what your system, your organization needs to be able to do, even under a specific condition or in a scenario. So my expectation or my hypothesis is our monitoring tool, Lumigo, recognized this scenario, the outage, within of 90 seconds and reports it to the relevant team on call via PagerDuty. That's, again, the integration between Lumigo, it's detecting an issue, and it's calling PagerDuty, hey, something goes wrong here. Please take a look at it. So this means there needs to be an incident, and this incident needs to be acknowledged by the team on call within 3 minutes. And the team on call starts to investigate. That's something we already saw in the demo by Justin. They are able to see what went wrong, what data is already in my incident. Is there something else I need to get? So, but that's not where the story stops. As we have built a resilient system, we build it in a way that this system is able to get back into the normal status in normal conditions within of 3 minutes. That's our expectation. And because of that, the incident and our on-call team is able to see that, is able to see that the resilient system has recovered and now is working normally. This also means that the incident that it needs to be resolved. It needs to be resolved within of 4 minutes. So you can see a lot of expectations, a lot of stuff is going on. Feels like a little bit complicated, but isn't. So why? Because now you can see really the interaction between all 3 tools in a very special way. Let me describe it again. So the timeline. We will start with a latency spike and a total outage in our online shop. This has been recognized by Lumigo, which will cause to an incident. So Lumigo will tell PagerDuty, hey, something went wrong, an incident has been triggered. Followed by an acknowledgement by the on-call team within 2 minutes. And the system, thanks to our resilient work and fallback strategy and Kubernetes stuff, whatever, the system is getting back to normal. Which also means, hey, the incident is gone. It needs to be resolved, but we need to store all the data. So, and that is something Steadybit can do for you in an automated way, and we can check if everything will happen like in this timeline. So, and to point one core element, or to make it, to point out, it's important not testing how fast an individual person can fix something. No, it is really like, it's about how good the organization you are working in is able, first of all, to detect an issue, if you are blind for 1 minute, 2 minutes, or 10 minutes, and how fast you can fix this fault, and if all the processes are coordinated. So that's why you need all three tools to train yourself to be proactive and not just to wait until in production something went wrong to see if an incident was triggered by PagerDuty. That's too late. So let's be more proactive. Getting into Steadybit again. That's the experiment I created, and that's also like the same timeline. So I'm just generating a little bit of base load, and I'm checking the UI, the online shopping tool. In the first 30 seconds, Steadybit is doing nothing, just checking if the system is healthy or not. After 30 seconds, the latency spike will be injected by Steadybit in the hot yield service, like we saw it in the incident. And that's also a very nice way where you can start from an existing incident. Maybe everything is documented in a postmortem analysis with PagerDuty. Now you would like to recreate the same condition. That's easy to do with the data we can see in PagerDuty and the possibility to do it with Steadybit. So followed by the latency spike, there is a total outage of the gateway service. That's the job of Steadybit, where we can inject the bad behavior. Now, the first trigger, the first check. After 90 seconds, Steadybit will call PagerDuty via API to see if an incident for a specific service was triggered. If so, the experiment will continue. After 2 minutes, we would like to see that the on-call team is able to know what's going on and has acknowledged the incident. So someone is working on that incident. That's something we would like to see after 2 minutes. Now, after 3 minutes, the system is getting back to normal because the Kubernetes cluster is taking care, the fallback strategy is working, so the UI is getting back to normal. And that's also something I will check with Steadybit with just one request to see, okay, everything is back to normal. Now, the last element, after 4 minutes, my expectation is that the team on call needs to be able to see that the system is working back to normal and has resolved the incident. That's the scenario, and that's something I also recorded because this is running around 5 minutes. So let me jump into the recording. That's a live view in a fast forward. So we are injecting the bad behavior, total outage of gateway. Now we are waiting for the triggered event or incident is triggered in PagerDuty. It was successful. So we are quite sure that the integration between Lumigo and PagerDuty is working. Incident was now acknowledged after, what was it, 2 minutes? Moving fast forward. You can see also in the responses that the system is returning back to normal. Our expectation is after, what was it, I guess 3 minutes. Successful, moving forward. Now we are checking PagerDuty again, because now the on-call team needs to take care about the incident because everything is back to normal. So it's been resolved. So the scenario is completed. But there was one finding at the end. Whoa. Let me move here. Come on. Okay. There was one finding where around 86% was our success rate. Maybe that's okay. Maybe we would like to improve this to get it up on 90, 95%, but that's just a tiny little detail. So, and that's it. Now we are in our Q&A session. If you have any questions, let us know.
I mean, totally conscious. There's been a lot of technologies talked about this evening, but I mean, if you have any questions, would be great to interact.
We can give it a minute, but otherwise, while we wait, I just wanted to say thank you to Justin, Benjamin, Barry for a great presentation today. Great to see how all of the tools can work together to provide, great resilient systems for our joint customers. And then the first question to come in here as we're talking, is it possible to implement self-healing steps instead of waking up support team at 3 a.m.? I think that's probably towards you, Justin.
Sure. Yeah. Yes. So it is. I mean, it totally depends on what the steps are, right? Quite often, if you actually look at the patterns of a lot of incidents, there's two parts to it, right? There's the part of, right, well, let's get things going, let's get things working, and then of course you've got a longer term sort of resolution that you might need code changes, for example. So self-healing is not going to go off and rewrite your code for you, but quite often, if it are things like that could be quite predictable, restarts, or scaling up some resource, or maybe starting services, things like that, all very doable. And the idea is that you would do that before you wake somebody up. Pavel, we want to do that first, and then if that does fail, go through an escalation process, or actually just generate the alert from that point as well.
Perfect. Thank you, Justin. We had another question here came across for Benjamin. What kind of experiments can Steadybit do with AWS Lambda, DynamoDB, etc.?
So Steadybit is designed in a way that there are so-called extensions, and extensions are the components that are working with your technology, like Kubernetes, or in the example of AWS. We are able to interact on AWS level with an API, so that we can, for example, simulate an region outage and zone outage. We can shut down 10,000 EC2 instances if you're running at that scale. We can do a failover of your RDS instance. So there's a big list of potential attacks you can run, and they are all listed on our site hub.steadybit.com. There's a section where you can get around, I guess, 80 attacks in total.
Nice. And then Benjamin, what specific health checks does Steadybit do before launching an experiment?
That's up to you. So we have a lot of integrations into all main monitoring tools, so that you can ask your monitoring tool, hey, is my system up and running? Or you can do it as I did in the experiment with just a simple HTTP check, where you can send out a GET request, and this needs to be in a specific status code. That's also something we can do. It's again close to the technology you are running on. There is most of the time also a health check we can provide for you.
Perfect. Thank you. That was the questions we have had so far. If anyone has a last minute question, feel free to go ahead and drop it in. Otherwise, we'll be happy to give 5 minutes back here. No. All right. Well, again, thank you, Justin. Thank you,
There's
Benjamin.
one question. One last question.
Oh, yes. This recording will definitely be shared with everybody who is here in attendance. So please look for that in your emails. And then from there, you can happily, ask any additional questions that you might have once you've had a chance to comb through all the different technologies that were discussed today. So again, Justin, thank you. Benjamin, thank you. Barry, thank you. Great presentation. And look forward to seeing all these technologies evolve here in the near future. Have a great day, everyone. Thank you again for attending, and you can look for that recording in your email soon.
Thanks, John.
Thanks a lot.
Thank you.